let's work together to learn how to draw Lewis structures. Now, some of these you already know how to do, such as Lewis structures for atoms, where you have an element in the center, the elemental symbol, and then you have the number of electrons around it, and these are the valence electrons. So carbon has 4 valence electrons, so we put 1 electron on all sides of the carbon for north, south, east, and west. 4 of them go around it. Nitrogen has 5 valence electrons, so we put 5 around it. Now notice we're going to refer to them as pairs, so they're always single, and we got some pairs going on. Here we've got ions, so where nitrogen gained 3 electrons, electrons are negative, you put the charge around it and you show that it now has 8 electrons. Magnesium used to have 2 electrons, it lost 2, becoming a 2 plus charge. Some Lewis structures are a bit more complicated, and so here you see a Lewis structure for some covalent compounds and then a polyatomic ion. And so when you're drawing those, I like to use a certain set of rules. It's just a process that I follow, and I really go step by step in order to figure out, how do I know this had 3 bonds? How do I know there were 4 bonds on this compound? And why were there 4 bonds on this one? But all in all, this process will kind of walk you through step by step to get you to drawing a Lewis structure for these more complicated compounds. Now, the one thing to note is polyatomic ions are covalently bounded within it, but the group has a charge. And so you have to put the bonds between them to represent covalent bonds, but then you put brackets, and then you put the charge on the outside. So now it can act as an ion, the whole group acts as an ion, but within the molecule there are covalent bonds. So here are the rules that I like to use when I'm drawing Lewis structures. Go ahead and pause the video and write these down, and then we can talk about them. So step 1 is just trying to teach you how many bonds do you have in your Lewis structure. If you do this step-by-step process, you'll be able to calculate how many bonds you have. So you first determine the number of valence electrons you have, and then if the molecule is negatively charged, you add electrons. If the molecule is positively charged, you remove electrons, and then you determine the total number of electrons needed by all the atoms in your molecule. If then you take needs minus halves divided by 2, that'll tell you how many bonds you have in your Lewis structure. Then step 2 is you want to figure out how to draw your Lewis structure. So you place that least electronegative atom in the middle, except for hydrogen. Hydrogen never goes in the middle. It always has to go on the outside because hydrogen can maximally only have 1 bond. Place everything else around it, then fill in your bonds, and then fill in your electrons. And then step 3 is check your work. Now that may have seemed like a foreign language to you, and don't worry, it does for a minute, but then once we finish with these next 4 examples, hopefully you'll be able to do this on your own. So let's go ahead and work some. The first structure that we're going to do is we're going to draw the Lewis structure for NH3. So what you want to do is you first want to locate nitrogen and hydrogen on your periodic table. So pull out your periodic table and circle them. That's what I recommend doing. And then ask yourself, how many valence electrons does hydrogen and nitrogen have? And what you should have noted is above hydrogen there was a 1, so it has 1 valence electron. Above nitrogen, there's a 5, so it has 5 valence electrons. So I have 5 electrons on the nitrogen and 1 electron on the hydrogen. But I have 1 nitrogen number of atoms and I have 3 hydrogens. So I've got 5 times 1 gives me a total of 5 electrons that are coming from my nitrogen, and I have 3 electrons that are coming total from all my hydrogens, which means I have a total of 8 electrons available to use. I can't just pull electrons from random space. They had to have come from an atom. Alright, so then you calculate how many you need. Every electron wants to be stable. Every atom wants to be stable. So in order to be stable, they're going to take on that noble gas configuration, which means hydrogen and helium. Hydrogen wants to be like helium. It wants to have 2 electrons. Every other element is going to want to have 8 electrons in that valence electron shell. So nitrogen needs to have 8. Hydrogen needs to have 2. And then remember, nitrogen, we have 1 atom. There's a subscript 1 here. And then hydrogen has 3. It was just an understood one. And then hydrogen, we have 3. So 2 times 3 gives me 6. 8 times 1 gives me 8. 8 plus 6 gives me 14. So now what I do is I take my needs minus my haves divided by 2. So you go 14 minus 8, parentheses, then that's going to give me 6. 6 divided by 2 gives me 3, and that's going to tell me how many bonds I have. Then we draw the structure. So the first step is to draw the skeleton. So you place the least electronegative atom in the middle, and that's going to be nitrogen. Not because it's the least electronegative, but because you can't put hydrogen in the middle. So it by default gets to go around the outside. Okay, nitrogen is actually more electronegative. That's why it's a 3. Hydrogen's got a 2.1 here. Nitrogen goes in the middle. Then we place 3 bonds around it. 1, 2, 3. Then let's count how many electrons we've used up. 2 are in every bond. Remember that? Every line represents 2 electrons. So we've got 2, 4, 6 electrons already on this structure. We go back to how many we have. We have 8 electrons, which means we have 2 remaining to place somewhere. Do I place it on the hydrogens? Do I place it on the nitrogens? Hopefully you realize hydrogen's already happy. It's got 2 electrons associated with it. It's sharing 2 electrons, so therefore it's happy. Whereas nitrogen has 6. It still wants 2 more. So you would place them right on the nitrogen, and now nitrogen's happy and hydrogen's happy. So this is the point where I suggest checking your work. So how I check my work is I count how many electrons total are on the compound. 2, 4, 6, 8. I have 8 electrons in my structure, and that matches the number I have available from atoms. Let's look at our next structure, carbon tetrachloride. So first off, we've got carbon, 1 carbon, and 4 chlorines. So we got to find our carbon on the periodic table, and it's right here, and chlorine's over here. And then we look to see how many valence electrons are in each of them. Carbon has 4, and chlorine has 7. Remember, once again, we get that from our group number. Then we need to count how many electrons we have available coming from the atoms. So in this case, carbon has 4, that's the number above it, and there's only 1 carbon atom. Chlorine, there's a 7 above it, but there's 4 of those atoms in the molecule. So we take 4 times 1 to give us 4, 7 times 4 to give us 28, 28 plus 4 gives us 32, which means I better draw 32 electrons on my molecule. Now, how many do I need? Remember, hydrogen wants to have 2, the other atoms want to have 8. So each of my carbon and my chlorine wants to have 8 electrons in order to be happy. So carbon, 8 times 1 gives me 8. Chlorine, 8 times 4 gives me 32. So I have a total of 40 atoms, electrons, that I need to place on these. So I need to have octets that are satisfied, and that's kind of what need is referring to. So now I do the funny math where I go need minus have divided by 2. 40 minus 32 gives me 8. 8 divided by 2 gives me 4 bonds. So I place my least electronegative atom in the middle, which is carbon. I place that in the middle, and I put 4 chlorines around it. That's my skeleton. That's what we call it, because it's just the bones. So now we have our carbon tetrachloride, and we need to draw 32 electrons total around all the atoms total. So first off, carbon here in the middle, it looks pretty happy because it's got 2, 4, 6, 8 around it. So it's considered already satisfied, which means I'm just going to start putting them all around my chlorines until my chlorines are happy. So I'd put 2, 4, 6 around this chlorine, and it already has 2, which means it's going to have 8. So I'd put 8, 8, 8, and 8, and that's going to give me 32 electrons that I just drew around my entire structure. Check your work. Count every dot individually and then count the bonds, and you'll count that you have 32 electrons that you've drawn on your structure. Therefore, it's a correct Lewis structure. Next, let's look at the polyatomic ion carbonate. Now, drawing this structure is going to be a little tricky because at the end we have something called resonance. But we don't cover that in our textbook, so I wouldn't worry about it. For our sake, it's going to be come up with the Lewis structure according to our rules, and we're going to be happy with that. So let's draw a Lewis structure for carbonate. First off, once again, you found carbon, it's in the 4th group, so therefore it has 4 valence electrons. Oxygen, it's in the 6th group, so it has 6. So draw your chart and figure out how many total electrons you have available from your carbon and your oxygen. So what you should have done is carbon, you have 4 electrons, valence electrons, and you have 1 carbon atom. Oxygen, you have 6 valence electrons and 3 carbon atoms. So that gives you 4 times 1 is 4, 6 times 3 is 18, 4 plus 18 is 22. But there is a 2 negative on here. So if it's 2 negative, what subatomic particle is negative? Electrons. So how many electrons did we add to our carbonate compound? We added 2 extra electrons. And so in doing so, you must add 2 electrons to that 22 to give you a total of 24 electrons that you have available. You have to draw the structure with all of those 24 electrons. So now, how many electrons do we need? Each carbon and oxygen needs 8 electrons. 8 times 1 gives you 8. 8 times 3 gives you 24. 8 plus 24 is 32. So now we know we need 32 electrons to be happy. So need minus have, 32 minus 24 is 8. 8 divided by 2 is 4 bonds. So I need to draw 4 bonds around my center atom. Now carbon and oxygen. Carbon is more electronegative, so carbon's going to be in the center, and then I just need to draw 4 bonds around it. Now this is where that resonance goes from. How do you know if this bond here goes to this oxygen or this oxygen or this oxygen? You don't. It's symmetric. It could go to any of them. And so that's what the term resonance means, is this bond kind of like hops around to all of them. Okay, it's kind of shared. But for our sake, let's just pick an oxygen and put it with it. It doesn't really matter. Okay, so now we've put all our bonds on here, and now we have 24 total electrons we need to put on the compound. So if this oxygen already has 4, it needs another 4 electrons here, and this oxygen needs another 6, and this one needs another 6. And that would give us a total of 8, 16, 24 electrons around the entire ion. And then in addition to that, don't forget, since it's a polyatomic ion, you need to put brackets around the compound and put the charge on the outside of the compound. Now let's do it for water. Water is probably one of the most common Lewis structures that you will be asked. Water makes up 70% of our planet. We drink it, we survive on it, so therefore it's very important. We're going to talk about polarity next. Water is crucial in helping you understand polarity. So find hydrogen on your periodic table. How many valence electrons does it have? You should say 1. Oxygen, 6. So that's how many we have. 1 times 2 gives us 2. 6 times 1 gives us 6. So we have a total of 8 available. Hydrogen wants to have 2. Oxygen wants to have 8. So we need 12. 12 minus 8 gives us 4. 4 divided by 2 gives us 2 bonds. So we draw our hydrogen connected to an oxygen, connected to another hydrogen. You could have drawn it to look linear. That's fine at this point. And then we ask ourselves, how many electrons have we used? And we've used 1, 2, 3, 4, and we have 8 available to us. So 8 minus 4, we need to draw 4 more electrons on that oxygen. And now they are all happy and content. And so that's how you draw Lewis structures. It's really just kind of a systematic approach of make sure you put the least electronegative in the middle, put the right number of bonds, fill in the remaining electrons around the outside. Now go read section 4.11 and 4.12.